Okay, so Sarah, we discovered that the video cut out kind of towards the end of this. I believe where the video cut out was right here, where we were breaking the electric field due to 1 into its Y component. Okay, so the Y component, we've used the sign. We've got, so we would put that in. We get this, and we should have gotten this value for the Y component. Okay, which means in the component form, our electric field due to charge 1 in the X direction is this, and in the Y direction is this. Now, notice when we solved this, we had a negative here. And remember what the negative at this point means. It means that it's going towards that charge. Well, at this point now, we're not interested in whether it's going towards the charge. We want to know, is it in the positive or negative direction? Well, in the X direction, E1 is going in the positive direction. So it is this big in the positive direction. We've changed our definition of what a negative means. Okay, so in component form, this is what E1 would look like right here. So here's what we need to do. We need to add E1 and E2. We add them by components. The X components together and the Y components together. E1 is the only one that had an X component, but both E1 and E2 had Y components. There was the Y component for E1, the Y component for E2. We combine those together. So here is our electric field. Going back to our diagram, here's E, the size of E, in component form. But we want it in the magnitude angle form. So basically we're going to use the Pythagorean theorem to find out how big E is. Okay, and you'll want to go through this calculation yourself. By the Pythagorean theorem, it's the square root of the X component squared plus the square root, or plus the Y component squared, the square root of that whole quantity, which gives you this. We also need the angle. Our angle is the inverse tangent of the opposite over the adjacent. In this case, the opposite is our Y component. Our adjacent is the X component. Put that in, you get an angle of 76.1 degrees. So here's how big our electric field is, and here's the direction. Okay, if I go back to the diagram, what we said earlier was it's going to go up. If we'd have looked and talked about it closely, what we would have realized is Q2 is located closer to point A, so its impact or its effect is greater. So it will be more going up than it will be going to the right due to E1. So we would expect it would be at some angle bigger than 45, which in fact we got 76. Okay. So this is why people generally like dealing with potentials and potential energies a lot better, because you don't have to deal with the directions, especially when we're talking about the electrostatics here.